Now let us see a program to illustrate column major order. How to enter items and display the items according to the column major order. Because row major order, as I told, naturally we do it by default. No need to mention. Now let us go to the program. Hash input iostream.h void main int a of 10 rows and 10 columns I have taken. I, J, R and C. R and C are the number of rows and the number of columns. You can take also row or column or any other symbol like M and N. I have taken R to represent the number of rows, C to represent the number of columns or column size. See out, enter the order of the matrix. It is number of rows and number of columns. C in R and C. Enter the elements into the matrix. But while entering, you can observe this. For I is equal to 0, I less than C, I plus plus. Next for loop, inner for loop is J is 0, J less than R, J plus plus. Observe here. Usually first row, first loop is to take rows first. All the items of the first row according to the row measure. But in column measure, this is column measure. Look at this. I have taken the number of columns first for the outer for loop. Number of rows in the inner loop. Correct? That means I am taking items for the column measure. Here also, see in A of Ji, there I interchange. Right? A of J and I. Normally it is Ij. Here I should interchange that. J and I. So number of columns and the rows. Column index Ij and row index. So here the row index becomes the column index here. Correct? That's it. So here is a difference. Only for the entry there is a difference. Correct? Columns first, rows next. Here also see in A of Ji. Correct? Next, displaying the items of the matrix or two-dimensional array is the same. First for display, first for loop to display the items of the row only. Now see the difference. The difference is only in storing the items of the given array in memory. Correct? But when we are displaying the items, there is no difference. Display is just like the matrix will display. Correct? For example, in this case, if you enter like 1, 2 and 3, 4, 5 and 6, right? 2 rows and 3 columns. Naturally we enter like this. But when you display according to the column measure order, as stored in the memory according to the column measure order, same thing will be 1 and 2, 3 and 4 and 5 and 6 like this. These items will be stored like this. We are continuously giving the items 1, 2, 3, 4, 5, 6. Correct? While entry, we don't bother whether we give by giving a space or line wise. No. Right? These are taken. But how the items are stored in the memory, that only is the difference. Right? So here we take number of columns first, column wise first, column wise, and next the row wise. So 1, 2, 3, 4, 5, 6. Are you getting this? 1, 2 first, right? Next 3, 4, next 5, 6. But while giving, we have given 1, 2, 3, 4, 5, 6 in this order. Correct? Okay. So how to display? Naturally, first for loop for the display purpose, displaying the items. First is for the rows only. Second is for the columns only. There here we don't have any change. Outer for loop for the rows, inner for loop for the columns, and here also see out A of Ij. Don't interchange. Naturally, natural order Ij. Row index first, column index next. ZW is to leave some space here between the items. That's all. Right? It is only for the display. So usually the items of the matrix are displayed like this: two-dimensional array, two-dimensional matrix. For loop with the open brace here, and inner for loop display the array items, and one line break after you display the item. So first here it is like this. There is a line break. In the next line, the other items must be displayed. So this is only for the display, right? Display, we are showing that this is how they are stored in the memory. Correct? 1, 2, 3, 4 and 5, 6. That is how we should understand. Whereas displaying of the items, there is no difference. Correct? That is why it is taken naturally row and column. Next, I and J only. Hope you have understood this. The only difference here when we enter the items, That is how they will be stored in the memory locations. First column items first, second column items next, and the next column items next, like this. Column major order. Hope you understood this. After this, the last section of the array section is advantages, applications, and disadvantages of arrays. To mention the advantages of array, applications of arrays, as I told, arrays will be used in implementing various other data structures, right? Like stacks, queues, even heaps. Other data structures or other complex data structures are implemented using arrays. So that is the very important application of array, to implement other data structures, applications. One, to implement other data structures. Other data structures like stacks, queues, etc. To implement even two-dimensional matrices, mathematical vectors, and two-dimensional arrays, right? Like matrices of numbers or characters or any symbols. So implementation of other data structures, and also in the other application of this one is, as I told here, in databases, right? To manipulate the database, store database records. What are each records? Each record in the database is nothing but one-dimensional array, right? 1D arrays. One-dimensional array. Every record in the database, records are a collection of values for some columns, correct? Set of properties. One set of data for a particular instance of a database table, right? So one row or record is represented using a one-dimensional array. So thus in storing the data of a database, internally one-dimensional arrays will be used, right? So extensively these are used to manipulate or store large amount of values of similar types in groups of data. These are some applications. And even same thing we can quote for the advantages of arrays. Arrays find a lot of advantages, like as we have mentioned, group of or large amount of data elements of the same type. Large amount of data items of the same type can be manipulated using the arrays concept, maybe one-dimensional, 2D or multi-dimensional arrays. So otherwise it is very difficult to manipulate, right? Suppose hundreds of numbers, integers, how to manipulate? Individually we have to declare separate variables, which is not at all worth. It becomes a very complex process to program. So arrays having the same name, collection of homogeneous items of the same type. So this is a more convenient way of dealing with the large amount of data of the same type. So dealing with the large amount of numbers, processing large amount of data of same type, arrays will be extensively used. As I told, in the matrices and in implementing higher order complex data structures, arrays will be utilized. These are some advantages. And the disadvantages, there are some disadvantages or demerits of arrays. Demerits. What are those? Arrays are actually static structure, right? Arrays are static structure. What do you mean by this? The size of the array is fixed. Size is fixed at the compile time. When we declare an array, the size should be known. It is fixed. Suppose A of 10. Only 10 items can be stored there, manipulated. Not more than that, right? So what happens is, naturally, when it comes to extending the number of items, it is not possible. So in case we require more number of items at the time of running the program, it cannot be accommodated because the size is fixed at compile time, being the static structure. It is not possible to extend. Suppose we require less number of items. Suppose we declare something like array of 100, but at the time of processing, running the program, we may require only 5 to 10 or maybe 20. All other remaining memory locations which are in advance declared becomes waste of memory. So either there is a scarcity of memory because the fixed size of the array, we cannot extend to accommodate more number of items. But at the same time, it can be wastage of memory also. In case we declare a large size array in advance, it may not be necessary. So in both the cases, there is no flexibility, right? So whatever the memory locations allocated, fixed it is. It is not possible to change. So this itself is a major demerit of arrays. And one more thing is, since the array size is fixed, static, dynamic allocation of memory, right? At the time of running the program, memory cannot be allocated. It becomes static memory allocation, so which itself is the demerit. And during the processing of array items also, like for example, we have seen insertion of items and deletion of items from the array, one-dimensional array, where if the number of items are more, it takes more time to shift the items, right? Inserting the items and deleting the items involves a lot of shifting operations, right? Dislocation operations, moving the items from different locations to the next or the previous locations, which takes much more time and becomes very much complex in the case of static arrays, right? Moving the items between locations. Whereas in the case of dynamic structures, like we are going to see using linked list, insertions and deletions becomes very much comfortable and easy. So that is difficult in the case of arrays, static arrays, because it consumes a lot of time. So these are some demerits of arrays being the static structures. So those demerits can be overcome by using the dynamic structures called linked lists, which make use of pointers. That we will see in the next section in linked lists. So this is all about arrays. Thank you.